Assalamu alaikum wa rahmatullahi wa barakatuh. So, Muti Solana, before I say this question, the first question you ask about, I think it's about mapping or something like that. So I will check that if I can do it. But let's go with this one first. This is easier for me because it is chemistry question. So the question says a hydrocarbon on combustion gives 0.704 grams of carbon dioxide and 0.216 grams of water. The relative molecular mass of the hydrocarbon is 57. Calculate its empirical and molecular formula. So we'll start by looking at what they gave us. So the given values are, they give us 0.704 grams of carbon dioxide and they give us 0.216 grams of water, H2O. So the first touch is to convert the grams to mole, and then you know that you use the formula number of mole equals mass over molar mass. So if you do that for carbon dioxide, we need to get the molar mass of carbon dioxide first. Remember, the molar mass of carbon dioxide is carbon, which is 12, plus oxygen. There are 2 atoms of oxygen, and then oxygen is 16. So if you add it together, you get 44. That is the molar mass of carbon dioxide. For water is H2O. There are 2 atoms of hydrogen, and molar mass of hydrogen is 1 plus and only 1 atom of oxygen, which is 16. If you add this together, you get 18. So the relative molecular mass of water is 18 and that of carbon dioxide is 44. So we can convert the mass of each one of them to mole from that using mole equals mass over molar mass. So mole of carbon dioxide is going to be the mass of carbon dioxide, which is 0.704 divided by the molar mass of carbon dioxide, which is 44. And then we do the same thing for water. Mole of water will equal to the mass of water, which is 0.216 divided by 18, which is the molar mass of water. So if you press our calculator, 0.704 divided by 44 equals 0.016 mole of carbon dioxide. For water, that does the same thing, 0.216 divided by 18, which is equal to 0.012 mole of water. Now, so we've gotten the mole of water, and then we've gotten the mole of carbon dioxide. Now we look. Remember, they said the compound is hydrocarbon. So the compound, when they say hydrocarbon, it means that compound contains carbon and hydrogen atoms only. Now, if you look at this, they said mole of CO2 equals 0.016. So it means that mole of CO2, the CO2 contains, you know, when you see CO2 like this, it means 1 like this. 1 of CO2. That is it contains 1 carbon and 2 oxygen atom. So if 1 mole of CO2 contains 1 carbon, it means 0.016 mole of CO2 contain 0.016 mole of carbon. So I want to put mole here. So mole of carbon. So what this one means is this. When we get 0.016, so it means 1 mole of carbon dioxide contains 1 mole of carbon. So we have gotten mole of carbon in 0.016. This is what they gave us in the question. 0.016 mole of carbon dioxide contains 0.016 moles of carbon. So on our side we pay CO2 like this. CO2 we pay 1 carbon and 2 oxygen. So, and then they now say CO2, the mole of CO2 is 0.016. So if the mole of CO2 is 0.016, we the mole of carbon here is 0.016, and the mole of oxygen is 0.016 times 2. Yeah, so we leave that alone. At get a mole of carbon by hydrogen. So we'll get that of hydrogen from water. I'm going to get a mole of hydrogen from the mole of water. So let's go. We know that H2O. So please give me one moment. We know that H2O. Let me pause. So H2O, when you see H2O like this, remember it means 2 hydrogen atoms and the ratio 1 oxygen atom. The way we did for carbon dioxide here. Carbon dioxide has 1 carbon and 2 oxygen. But water has 2 hydrogen and 1 oxygen. So hydrogen la need in. Now 1 mole of H2O contains 1 mole, it contains 2 moles of hydrogen. Contains 2 moles of hydrogen. 2 moles of hydrogen. How do you know? I didn't be by already. So there need 1 mole of omi by. You know 1 mole of omi here. Hydrogen méjì ló wà ńbẹ̀, oxygen ẹyọ kan. That's what I did here. So ìyẹn la fi wá lò tá fi wá get the mole of hydrogen question wa lókè bí the amount of water that we get up here. So let's go back. From what we get up there, also we get 0.012 mole of water. So 0.012 mole of water will contain 2 times 0.012 mole of hydrogen to contain here, because 1 of water to contain 2 of hydrogen. So 0.012 will contain 2 times 0.012. So it means it contains 0.024 mole of hydrogen. So I get a mole of hydrogen and I get a mole of carbon now. So we can calculate the empirical formula of the hydrocarbon. So let's go. The hydrocarbon contains carbon and hydrogen atoms only. So I did get a mole of carbon. The mole of carbon is 0.016. Abi? Yeah. And then the mole of hydrogen is 0.024. So I put mole here. Now all we need to do is to divide by the smallest of the two. So if I get the empirical formula, we have to divide by the smallest. The smallest of the two is 0.016. So 0.016 divided by 0.016, and then 0.024 divided by 0.024. So this will be 1, and this will be, sorry, I made a mistake, not 0.024, 0.016. We are dividing by the smallest, 0.016. So 0.024 divided by 0.016, so do we get 0.024 divided by 0.016? So what do we get? We get 1.5. 1.5. So it means carbon is 1. The empirical formula can be, it's not this anyway, so there's the hydrocarbon contains 1 carbon and 1.5 hydrogen. So this one, we normally write this formula in a whole number, 1 and 1.5. So we don't want fraction. We want to convert it to a whole number. What do we do? Without losing anything, we just multiply. We'll find a way to make this one a whole number, 1.5. If you multiply 1.5 by 2, it will give us 3, which is a whole number. The same thing, we are going to do it to this one as well. 1 times 2 is going to be 2. So 2:3 is the same thing as 1:1.5. So it means the empirical formula now, which is a whole number, AF, the empirical formula of the compound is C2H3. So this is the empirical formula, C2H3. What about molecular formula? That is easy. Empirical formula times a unit, N, is equal to molecular formula. Now, the empirical formula is C2H3. So we just put C2H3, put it in bracket, times N will equal to molecular formula. So molecular formula, I'm change the molecular mass. Remember, molecular formula of water is H2O, which is the same thing as 18. So this is molecular formula, this is molecular mass. What if one molecular mass of that compound, which is 57? If you check, it is 57. So instead of writing molecular formula, just write 57 there, because I bet the calculation is in the number I need. Then I might change the empirical formula here and see empirical mass. So we know that we have carbon is 2 and 2 carbon atoms, and carbon is 12. So it means 12 times 2 in bracket plus hydrogen. We have 3 hydrogen atoms, 3, and then hydrogen, molecular mass of hydrogen is 1. So and then everything times N outside here. So carbon 2 times 12 times 2 is 24 plus C, that is 27. So maybe 27N equals 57. So we can calculate N. N will equal to 57 divided by 27, which is approximately equal to 2. So N equals 2. If you check, I think I can remove this and do the calculation. So 57 divided by 27 kilo for 2.111, so which is approximately equals to 2. So the molecular formula, we remember the empirical formula equals C2H3. The molecular formula, we just multiply empirical formula by 2, because at N is equal to 2. So I can multiply by 2. So 2 times 2 is going to be C 2 times 2 H 2 times, sorry, 3 times 2, which is what? C4H6. This is the molecular formula. The one on top is the empirical formula. So you can look at it and then use it to answer the question. Assalamu alaikum.